behemoth. Okay, start. Question number 1. The recording of the yeah, okay, I will try. Just tell me which group you're from. Uh, that I know where you're from. Just mention which group did you join this meeting from. Akka Haji? What's that? Like which WhatsApp group? The other one. Okay, I'll just send in all groups. Okay, it can be yeah, okay, I'll send it there. Sure. Question number 1. A particle being of mass 5 kg is at rest on a smooth horizontal table. A particle A of mass 2.5 kg moves on the table with the speed of 6 meters per second and collides directly with B. The question is two particles coalesce. Bro, simple momentum question. This is A, this is B. A is projected towards B, speed 6 meters per second. And then after that, they coalesce. So what's V? Uh, just use the equation. M1U1 plus M2U2 is equal to M1V1 plus M2V2. Let's take first particle as A. The mass of A is 2.5 kg, 2.5 kg, and B is 5 kg. 2.5. Initial velocity is 6 plus 5 of B, which has an initial velocity of 0, is equal to V. They both have the let's do it separately. In fact, 2.5 V plus 5 V. We can take V common. 2.5 into 6, it should be around 15, I think. Yeah, 15 is equal to, let's take V common, 2.5 plus 5. So V we get is 15. You have a 7.5. So V is quite simple. Yeah. uh, Question number 1, part B. Find the loss of kinetic energy of the system due to the collision. So basically, the loss will be, since it's lost uh, to get positive, let's do like final minus initial. So final kinetic energy is half m. Since they coalesce, so it's a combined particle. So we just add the masses of both particles, 2.5 plus 5, v square, which is 2 square, minus initial, which is half the speed of both particles. M is 6, sorry, 2.5, mass of A, 6 square, plus half mass of B, speed of B, which is 0 square. So that really doesn't get 0. 2 cuts with 2, 7, this should be 15, minus, this is just, all of this is 0. 6 square, 36 divided by 2 is 18, into 2.5 should be around 50 something. That's 45. So basically, we the loss of kinetic energy in the whole system is negative 30 degree. So we just write the magnitude. Just 1 second. So 30 joules has been lost. Okay. Question number 2. A car of mass 1400 kg is moving along a straight horizontal road against a resistance of magnitude 350 Newton. Find in kilowatt the rate at which the engine of the car is working when it is traveling at a constant speed of 20 meters per second. Okay. quite simple. Amla, let's make the car. It's always best to like sketch or draw the situations so you know what is actually happening. So looks like an F1, mashallah. Okay, so it's going in this direction, right, at 20 meters per second, and it's facing a resistance of 350 Newton. And since it said that it's traveling at a constant speed, so that means there is no acceleration, right? Acceleration is zero. So acceleration is zero when the resultant force is zero, and that's only the case when the driving force will also be equal to the resistive force, which will be equal to 350 Newton. So the power of a vehicle is the rate of work done, which is F into d over t. This t and d we can write as velocity since this is over time, so it's F2. And the driving force uh we just like realize that it's 350 into velocity, which is 20. So we get 7,000. Yep. 7,000 watt. And since they've asked us to give in kilowatt, so we write 7 kW, 7 kilowatt. समझ आई boys?
हाँ.
क्या हुआ? Find the acceleration of the car when its speed is 20 meters per second and the engine is working at 15 kilowatt. Okay, so uh, acceleration is when they will be resultant force. So we know that P is equal to FP, right? And they've given us the power and they've given us the speed. So that means we can find the driving force from that. For driving force will be power over velocity, which will be equal to 15,000 20 750. Then 15 Newton. So let's take the car again. And okay, so see, they gave us the resistance of magnitude 350 in the question statement. So that means this will hold true for all parts. But they gave us constant speed in like in the specific part A. So that means that it is only true for this specific part. So since its resistance is in the question statement, so that means it still is facing resistance of 350 Newton. Now the driving force has changed to 750 Newton. So now we just put the sorry, E is equal to F, sorry, F is equal to ma. The resultant force is 750 minus 350 is equal to mass, which is 1400 kg, into acceleration. So acceleration will be 400, 1400. So it is 0.2 over 7 meters per second square. Or you can write it as 0.286, estimated to three significant figures. शाज़िब ब्रो, आपने क्वेश्चन किया, मैं आपको समझा दूं फिर से ये क्वेश्चन, अगर आपने लेट ज्वाइन किया.
नहीं नहीं, मैंने कर लिया. सुनिए.
अच्छा, आयशा आपको भी, अगर आपने लेट ज्वाइन किया मैं समझा देता हूँ. क्वेश्चन नंबर 3. Co-planar forces of magnitude 8 Newton, 12 Newton, 10 Newton, and P Newton act at a point in the directions shown in the diagram. The system is in equilibrium. Find P and theta. Okay. So let's analyze the situation. Okay. So we know that we have two variables. And we can, if since we have two variables and it's a forces question, and we can always resolve it to get to the components in two planes, right? The horizontal resultant and the um, vertical component. So let's find the vertical component first. I can estimate it's going to be downwards, it's 10 Newton. So the vertical component will be equals to uh, it doesn't matter what direction you estimate. If it is in negative the magnitude, so that means it's in opposite direction. 10 sine 45, i.e. this component, and there is no other component minus the component of these two forces, 8 sine 30 minus, let's say, add those components, 3 sine theta is equal. So this should be equal to, okay, since it's equilibrium, we can say it's equal to 0 since there is no resulting force. Minus p sine 30 sine theta. So that means that p sine theta is equal to, we get the clean answer, equal to -4. Let's write it like this. This is the first equation. Second, we can resolve it horizontally. 12, let's say it's in this direction resultant, plus 8 cos 30 is equal to p cos theta plus 10 cos 45. P cos theta is basically 12 plus cos 30 negative 10 cos 45. This is minus 4 plus 5 under root 2. And this is 11.8571. It's basically a lot bigger than that, but since it's not a fixed uh, value, so always take the values in calculations which you are going to use to its 4 decimal places. The that gives you appropriate accuracy in the final answer. From here, we can say that P is equal to 11.8571 over cos theta is 2. Let's substitute this in P in 1. We get 11.8571 over cos theta into sine theta equal to -4 plus 5 under root 2. So sine over cos theta is tan theta divided by 11.8571. Theta is basically the inverse of tan. Seven one. So we get is 14.5 to 09 degree, so approximately 14.5. So now let's calculate P, 11.8571 over cos. Let's take the more accurate value of theta, 14.5209. P we get is 12.2 degree. क्वेश्चन की समझ आई और लाल
जी आ गई।
हाँ, आ गई।
अलजेब्रा आपको आई है?
आ गई, आ गई।
क्या बात, अच्छा। हाँ यार ये था मेरा यार आपका लेवल ही हो रहा है ब्रो इब्राहिम
यार, अब्दुल्ला, जो
पार्टिकल।
आपने ग्रुप के अंदर भेजा था ना, एंड पे वो करवाना, जब ये पेपर कर लो उसके बाद।
हाँ ठीक है चलो मैं वो भी कराता हूँ वो। उससे उसने उसने मुझे भी बड़ा तंग किया था उस क्वेश्चन ने, तो मैं करा देता हूँ इंशाल्लाह। Particle P moves in a straight line. It starts from rest at point O on the line, and at time t seconds after leaving O, this acceleration with a is equal to 60 minus 18. Find the distance P moves before it comes to instantaneous rest. Okay. Okay. So first, let's get the. Okay, so they've asked for distance. Okay, so when they've asking us to find the distance, so the best way or the most like easiest and conceptually sound way to solve these distance questions is to like sketch the velocity time graph somehow. Like that's the easiest way. You can just integrate the expression and find the distance. So that's what we're going to trying to do that find the equation of velocity. So the velocity will be the integral of acceleration will be the integral of this. So if you integrate it, you get 60 square over 2 minus 18t plus c is equal. Okay. So let's see what's c first. C it starts from rest at point O, right? So at t is equal to 0, p is equal to 0. So if you put c is equal to 3, 0 square minus 18, 0, you actually get c is equal to 0. So the expression of velocity dt square minus 18t. Okay. So we know that the graph is going to look, it will be basically an upward opening quadratic graph since its expression coefficient of t square is positive 3. But let's just sketch it. Know that the initial velocity is 0, so it starts from here. And now uh let's find the minimum point, or if it comes to instantaneous rest. Okay, so instantaneous rest it's going to be 0, so we put v is equal to 0. That means 3t square is equal to 18t. Wait, no. Okay. 3t square minus 18t is equal to 0. Take t common. 3t is equal to minus 18 is equal to 0. So we get t is equal to 0, which is the starting point, and we get 3t is equal to 18. So t is equal to 18 over 3, i.e. it's around 6, right? 6. That means it's at instantaneous rest at 6. Let's say this is 6. And it's going to be in downward opening. And it's going to go negative, right? Uh, let's, for the sake of finding the graph, let's say, let's find the derivative, the turning point. Turning point is basically the derivative of v equals to 0. We already have the derivative of v, which is the acceleration. So let's say 60 minus 18 is equal to 0. So we get t is equal to 3. So at t is equal to 3, there will be minimum velocity or the maximum velocity. Let's find whichever it is. So we take t is equal to 6 and we put it into equation of V. This is not very necessary, but just to show you how to sketch the graph, so you can easily find the this distance. V6 square. Six. Sorry, 3. Need at Yep, it's negative 27. What I imagined. So it's, let's say this is the negative 27. This is what the graph actually looks like of the velocity time graph in the until it comes to instantaneous rest. So we need to find, we know that the distance of a velocity time graph is basically the this distance, right? The area under the graph. So, and we know this is 0, and we know that this is 6. So why don't we just integrate it? Integrate the expression of V to from the limits of 0 to 6. This is 3t square minus 8t. Integrating it will give us 3t cube over 3 minus 18t square over 2. Okay, sorry, I have a timer for meeting, so I'm just going to end the meeting and restart it again. Just after I ending it, so just rejoin the meeting when I end it, okay? So that I can avoid the 10-minute timer it gives at the end. Inshallah. I'm just going to end it right now.
ठीक
So
है
now,
ओके
limit 0 to 6. We cancel with 8, with 18, we get 9. T cube minus 9t square, limits of 0 and 6. So let's solve it. 6 cube minus 9 x square minus 0 cube minus 9 0 square. So we should get the distance now, which is 6 cube minus 9 into 6 square. It gives us negative 108. Since its graph is a negative opening, right? But we only need the distance. So the distance will be positive 108 meter. अच्छा ये समझ आया यार, ये मुझे बताओ. Guys, do you understand this? Like how we found the distance. Another way would have been like we find the expression of the displacement, but that would have been displacement, and we need to find um we need to find then the minimum point, and then find the displacement till t is equal to 3, and then again. So it would have been a bit longer, and for that you would necessarily need to find this minimum point. But in the graph, you can just like estimate, since it's 3t square minus 18t, just put t is equal to 1, and you get negative. So you would like know that it will be downward opening. So just you don't even need to know this value over here. You just know it's negative opening, then just put the limits 0 to 6 and then integrate it. Then this is the best way find distance in such occasions. Then this is what is in marking scheme as well. And it's easier, save time, saves time. Okay, again, so now, next question. Question number 5. Two particles of masses 0.8 and 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. System is released from rest with both particles 0.5 meter above the horizontal floor. Subsequent motion, i.e., the following motion, the 0.2 kg particle does not reach the pulley. So that the magnitude of the acceleration of the particle is 6 meters square and find the tension. Okay. So let's see the forces acting over here. So this is going to be, the weight of this is going to be 8 Newton. The weight of this is going to be 2 Newton. And tension is over here and over here, right? This T. So let's say if we consider the whole system, and if when we consider the whole system, the tensions cancel out. So what we get, if we look at from this perspective, the forward force, we need the acceleration, right? So we basically put F is equal to ma of the whole system will be, let's say this is the forward force 8 Newton minus the force which is this 2 Newton, since it's acting downwards and it's the same string, so it will also act over here as well, right? And over here as well, similarly. So we can say -2 is equal to mass of the whole system. This is very important. Like this is very important. I used to mess this up a lot. Okay, so what you get is 6/1. Oops. Is equal to 6 meter per second square. That's proven. Now we find the tension. Let's from the tension we just like look at from this perspective of the smaller particle, 0.2 kg. You know that F is equals to ma. So it has a weight of 2 Newton acting downwards and tension acting upwards. That's the only two forces that's acting upon it. So we can say T minus 2 is equal to mass 0.2 to acceleration 6. T is equal to 1.2 plus 2.2 Newton. That's the tension. When the 0.8 kg particle reaches the floor, it comes to rest. Find the greatest height of the 0.2 kg particle above the floor. Okay. So, uh, simplest way to do this, like we know, since it's 0.5 meter, so we just calculate its, and they both accelerating with the same acceleration, right? Same magnitude. So when particle A it hits the ground, the velocity of a of zero point 0.8 kg at this point when it hits the ground will be the same velocity of the 0.2 kg particle when it has moved 0.5 meter upwards, right? Since they travel the same distance as well. So we just calculate the uh, above the floor. Yep. So we just calculate the final velocity of 0.8 kg particle. Then we add it to, then we consider this as the initial velocity of this particle. Then we use it to find the maximum height it reaches after the 0.8 kg reaches ground. Then you just add that height, maximum height, uh, to this height 0.5 and this 0.5. So to 1. So we get the, let's say the final velocity to as is equal to v square minus u square. So the final velocity is 2, the acceleration is 6, and the distance is 0.5 plus 0 square since they both are at rest. So we get is 1/6. And now this is the initial velocity of the 0.2 kg particle when it's at, let's say this is now the scenario. This is the floor, this is the pulley, and this is the 0.8 kg particle, and this is 0.2 kg particle. And the total distance now from of this down is 1. So this is the initial velocity of the 0.2 kg particle. So we know that the V is equal to plus 80. Now the acceleration acting upon this particle will be -10, right? So velocity, to find the maximum height, we just add final velocity is 0. Initial velocity is 6 under root plus -10. Wait, why are we using this equation? Sorry. We should use this. So the final maximum height it will reach will be 0 square minus under root 6 whole square over 2 -10. 0.3. So basically travels 0.3 meter. So this is, let's say this reaches this point. So 0.3 meter from this point, which when 0.8 kg reaches the floor. So the greatest height above the floor will be 0.5, which was the initial height, plus 0.5, which is what it travels until 0.8 kg hits the floor, plus 0.3, which is what it travels with the initial velocity it gains from that acceleration. So it is 1.3 meter. इसकी समझ आई है क्वेश्चन की? ये भी इजी था यार। शाजिब, काबिल। शाजिब ब्रो, इसकी समझ आई है इस क्वेश्चन की?
यस यस, ये तो
क्योंकि
इजी है।
क्योंकि देख लो,
याद है।
ये M1 पे प्रॉब्ली डिपेंडेंट हो सकता है हमारा ग्रेड तो ना।
हाँ हाँ, M1 तो हो जाएगा
अल्लाह
फिर भी।
खैर, इंशाल्लाह खैर। कार ऑफ मास 1500 kg पुलिंग a ट्रेलर ऑफ मास, पहले कहना था वो तो हो गया ऑलमोस्ट। कोई नहीं, इसके बाद में वो क्वेश्चन करना है एक और जो मैंने भेजा था, बिल्डिंग वो डिफिकल्ट है थोड़ा सा। पुलिंग a trailer of mass 1050 kg upper stated length 18 meter science, so okay, since we were in the pattern forward. Okay, so basically that's the situation. That's very important. Use an idea of how to solve. So basically we know that sine theta equal to 0.08. Since it says that's angle of sine inverse, right? So let's say the angle is sine inverse of 0.08, right? So that means that sine theta will be equal to 0.08. And sine theta is what we actually need, right? We also need cos theta, but we can just inverse that. And uh, okay, so let's say this is the car, and this is the trailer, CNC trailer. Resistances is, since the trailer is 200, resistance to the car is 400. Right click the bar. Okay. And then they've given us the change in speed, so we need to know we have the, yeah, okay, I'll solve that, but we're probably going to have a tightness of time, so let's see, inshallah. If not in this class, I can solve it later, and I even record it. Okay. Energy method to find the constant driving force of the car. Okay. So we know that the change in energy is equal to change in work done. So let's see. Uh, so it says that the hill is 800 meter, right? So we need to find the increase in the gravitational potential energy. We need the h, right? And let's say this is a situation, right? It's something like this, and this is sin theta 08. This is 800. And this is h. We need h. So basically, you know that sin theta will be is equal to h over 800 perpendicular over hypotenuse. So h is equal to 800 to 0.08. Yep, that's right. So h will be equal to 800. Let's write this as 0 to 100. That's how we get 64. So the change in gravitational potential energy will be positive since it's going to gain the uh, keys, positive the total mass of the system. We considering the whole system, okay? 750 mass of the whole system into 10 gravity into h, which is 64, plus the change in kinetic energy, half m v square minus u square, right? That's it, basically the change. U square is 20 minus 30 square. This is equal to the work done by the driving force, which will be equal to force into the distance, which is 800, minus the work done by resistive force, which will be equal to the total resistive force is 400 plus 200, right? Into 800 again. This is how we need this F actually, the constant driving force. So if we simplify this, we should be getting the driving force as 1696.875, almost approximately 1700. समझ आया बॉयस? क्वेश्चन किसने किया? बस फिर आपको एक ना ये एनर्जी क्वेश्चन बन जाना चाहिए। अगर आपको ये आती है तो आपके सारे मसले हल हो जाएंगे, मतलब सारे मसले मतलब M1 के अंदर इस क्वेश्चन टाइप के, बाकी मसले तो फिर वॉइस ही होते हैं। After reaching the top of the hill, the system consisting of the car until it travels along a straight gravel road. अच्छा, सुबह रोड आ गई। Nice. Driving force of the car's engine is 2400 Newton and the resistance to motion are unchanged. Find the acceleration of the system with the tension in the tow bar. Okay, easy. So basically this is the road. Let's draw the cars real quick because we're lacking time. So no, we know that the total resistance is 600, 400 plus 200. Driving force is 2400. F is equals to MA 2400 minus 600. Since there is no weight, the resulting force will be acting upwards, uh, not inclined. Its full mass is 2250 to A. So we get the acceleration is 0.8 seconds square. ठीक है तो ब्रो, ये मसले फिर ना नमाज दुआ से ही हो सकता है। ये भी हो सकता है। नाइस। ये उससे हो सकता है बट वो इससे नहीं हो सकता, if you understand. Okay, so acceleration, we found the acceleration. So now let's isolate this trailer. So we know that there is a tension over here acting on the trailer. So the T minus the resistive force in the trailer, which is 200, will be equal to 1050 into acceleration, which will be 0.8. So T we get is 800. सवाल हो गया, टी इज कैंसल आउट। या व्हेन वी टेक द होल सिस्टम, जब हम पूरे सिस्टम को लेते हैं तब हम टी को, क्योंकि टी इसमें इस तरफ एक्ट कर होता है, टी इसमें इस तरफ एक्ट कर होता है, तब कैंसिल आउट हो जाता है। बट जिस तरह हमने अब टी कैलकुलेट करना था, तो अब हमने सिर्फ इसको आइसोलेट कर लिया, तो इसमें ये टेंशन हो गई और उसमें फ्रिक्शन हो गई। इसी, वरना उस समय भी कर सकते आप दोनों को, एक्सेशन निकालने के आप दोनों को अलग अलग आइसोलेट करके डिफरेंट एक्सप्रेशंस निकाल लो and then you equate them. But I find this one is much quicker and easier. Take the whole system initially, then we find the tension using acceleration. Okay, final question. Question number 7. There's no question after it, right? Yep, formula. 3 points A, B, and C. Yes, so 80, 1 meter. Yep, I was expecting this more than friction. Good to see. Okay, so basically to find the coefficient of friction in part B. Okay, given that mu is okay, find the speed of the particle. Let's see. So the acceleration of the particle, since it has the component of gravity is acting this, right? So its component of gravity acceleration is basically, wait, not the acceleration. Force is basically 0.2 into 10 into sine 30. Let's say the weight. So weight, the inclined weight. यार अफनान, आपको समझ आ गई थी? सॉरी, मैंने मैसेज आपका नहीं देखा, वो इंक्लाइंड वाला। पुलिस चैट में बेशक कह
हाँ
दो।
यार, वो हो गया था कंप्लीट। बस
हाँ
दूसरे
वो
कोई
मैं
सवाल
सॉल्व कर दूंगा, हाँ वो मैं सॉल्व कर दूंगा बाद में ना,
हाँ
क्लास
ठीक
के
है ठीक
बाद,
है तुम।
रात तक इंशाल्लाह। Okay, so we have force 1 Newton, F is equals to ma, so the force of resistance 1, total 1, resulting divided by mass, which is 0.2 a, so a we get is 5, right? 5. Okay, so what will be the speed at this point? So we know that 2as is equal to v square minus u square. Initial velocity will be 2 with acceleration 5, the distance is 1, or the displacement, same thing, and it is dropped from rest, right? Released from rest is 0 square. So V is basically under root 10. Okay. So now at point B, so now there is a friction acting, right? Since it's rough, and they're given us the coefficient of friction. So to find the acceleration, you need to do the weight minus friction. Friction is basically mu r, and r is basically the this force, right? The contact force. So to find the contact force, we just know that if you draw this right angle triangle, this is 90 minus theta and 90 minus 30. And if we draw the components like this, negative, so this will be 32. So, and this is weight, right? There is a contact force will basically be equals to mg to weight into cos theta. This is cos 30. Resulting force, the reaction force, in fact, we get is under root 3. So the frictional force is mu, which is half under root 3 into r, which is also under 3. So we get the frictional force as uh, 3, like 3 over 2, yeah, 1.5. So now F is equals to ma, the component of weight, let's take it above. So now over here, there is a frictional force acting of 1.5 Newton this way, and the weight is 1 Newton still. So the resultant the acceleration will be something negative. So it will slow down. Of course, it will slow down. That's since it's rough.
minus 2.5.
minus 2.5. यो अब्दुल रहमान, क्या हाल है ब्रो? कैरी कैसी है?
चल रही है ब्रो। बहुत बुरे
उसको
हालात
छोड़,
है।
रखा करो। मीडिया की कैसी? मीडिया की तो होगी आपको।
ऐसे लोग
हाँ,
कह
वो
रहे
सुबह का
लोग।
पेपर है, वो भी बस
हाँ,
सही है।
easy. Okay, so
दुआ करो।
um, so at C, it travels 1 meter again. Okay, so now the velocity at C will be equals to 2 negative 2.5 1 plus initial velocity, which we calculated was under root 10 whole square, to give us 10. So velocity at C will be equals to under root of 5. Part B, given instead that the particle comes to rest at C, find the exact value of mu. Okay, so to find if it comes, we just find the acceleration, right? With which acceleration? If we find the acceleration, then from there we can find the frictional force, and from that we can find the reaction force. Sorry, the mu. We all know the reaction force. So you know that 2as equal v square minus u square. So it's basically we need the acceleration, right? So v square, which is 0 square, minus the initial velocity, which was 10 under root 10 square over 2 1. Its acceleration should be equals to 5 minus 10 over 2. So it's if there is it will only come to rest at C if it has a negative 5 acceleration. So and we know that F is equals to ma. So the weight minus the frictional force. Since if mu is changed, that means the frictional force is also changed. Is going to be the mass of the particle into its acceleration. So the frictional force is basically Fr is equal to 1 plus 2. What? Really? That's good. It's a good number. You really get to see a whole number. Okay, so friction is equals to mu r. So friction, which is 2, is equal to mu r, which we calculated was mg cos theta. We just divide that by 2.
1.15 नहीं,
I'm
हाँ,
sorry.
1.15.
Sure. The correct answer though.
अच्छा वो 1.154700538। ओ सॉरी सॉरी, 2√3/3।
Yep, 2 और √3।
नहीं नहीं सर, अब्दुल्ला नहीं, 2 × 3 / √3 / 3।
एक ही चीज है ब्रो, इसको हम रैशनलाइज कर देना। इट्स लाइक रैशनलाइज दिस, दैट्स व्हाट यू गेट
ओके
2,
ओके।
this becomes 3 into √3, that's what you get.
ठीक है ठीक है।
So and this is equals to 1.15 if you're right. So I'm sorry if I may feel, wait, I don't understand why you take SS2 in the first statement. Where did I take SS2? I didn't take SS2. Okay, wait. Here, bro, it's SS1, bro. It's not 2. It's this 2 right here. Or is it something else which you're talking about? Uh, hold on. Yeah. Okay, I may feel a bit rushed. I may have rushed these last questions because uh, last time it's coming between here. Okay, then let's just like quickly do that bad question. I just explain this question, and then if the time starts, then I'll just bounce. Okay, how much time do we have? We have 2 minutes, inshallah. Okay, so basically, this question में हमने ये करना है. Okay, let's leave the question statement really quick. So this is a child. Basically, it's a swing. Okay, and they made it into a pendulum. Child, small particle p, and this was a difficult question. Guidance swings length 4 meter. Initially p. Given that there is no resistive force, find the speed of p when it has traveled halfway along the circular arc from its initial position. So basically, they're asking us to find p at this position, right? What's the speed of p over here? So what we need to do is we basically we know that they've given us the mass and then they've only given us the mass. So how do we find the speed? So if we know that we have the mass and we know that there is some height involved, so we know that it's going to be some game involving gravitational potential energy. So if we find the gravitational potential energy over here and then we find the gravitational potential energy over here, so which means there will be a loss, right? So if we can convert that loss of energy into kinetic energy and equate that with the formula, from there we can find the velocity. We basically need to know the different gravitational potential energies at this point. So to find that, we know that since this is 4, if we make a right angle triangle over here, and we know since this is 45, that doesn't look like this right line. This is 45, so this will also be 45. So this, we know that the sine 45, let's say this is h over 4, so it equals comes sine 45. Now this point, let's just take this again. So if we draw this line over here, so this angle will be half of that angle, i.e. 22.5, and this height, let's say this is h1, h2 will be and so since that is 22.5, so this will be 90 minus 22.5, 67.5 sine 67.5 h2 over this is again since it's the radius 4, so h2 we get is तो मुझे बोल हमारे पास बस बेसिकली ये हाइट चाहिए थी, अब आपका क्वेश्चन सॉल्व हो गया इस तरह. वी नो दैट दी सो द चेंज we basically the change in GPE, basically the change in kinetic energy since there is no resistive forces involved. So the change in GPE is let's say the initial sorry MGH 35 We'll take the mass and gravity common into the change, which initially was height was initially 4 sin 45. Wait, what am I doing? Okay. Minus 4 sin 6 45. So the thing will be equals to half 25 p square. So if we just like this cancels out 320.
मैथ एरर आ रहा है।
Anyway, एक सेकंड sorry.
मेरा में
Uh,
67 को पता लग
नहीं, sorry. The height is basically, oh man, I'm just made a very big blunder. So these H1, H2, so the height is basically opposite of, I'm sorry, this is the height, right? So we basically need to subtract it from the actual 4, this 4.
अजीज सीधा कॉस्ट ले लो ना।
हाँ सही कह रहे हो, cos होना चाहिए था। अ, तो बेसिकली, oh yeah, sorry, आसान हो गई हमारी की। So I'll just continue. I'll just send the finished solution. Let me just erase this in the recording when I upload it. Inshallah, I'll upload it soon enough. Inshallah, we'll just solve it over there. Okay. The whole solution, and I'll solve your question as well, if not, inshallah.
इसके
So
सॉल्यूशन का स्क्रीनशॉट ग्रुप में भेज देना या डीएम भेज देना।
हाँ ठीक है, मैं ग्रुप में भी और टीएम भी कर दूंगा इंशाल्लाह। ओके बॉयज, अस्सलाम वालेकुम। वालेकुम shared link. Okay. Which group? I'll just share it in all groups, inshallah. Hopefully, you'll find it.
मैं आखिरी सवाल था, वो पहले 3 सवाल देते थे, दरमियान में सो गया था ये।
क्या हुआ?
मैंने लिटरली दरमियान में पेपर मिस किया क्योंकि मैं सो गया था।
कौन सा? हाँ नहीं, रिकॉर्डिंग में सेंड कर दूंगा, मुझे टेंशन नहीं लेनी।
थैंक यू।
Assalamu alaikum warahmatullahi wabarakatuh. I had to leave earlier for prayer, so I promised to finish this question. Okay, so um, they've asked us to find the speed of p when it's halfway. Um, and it's over here when it's halfway around the circular arc. So basically, we need to find this change, this change of GPE, and then we can equate that change if KE kinetic energy. So we know over here, say, let's say this is a right angle triangle. Splits in so much, I don't know. So with this H, right? H1. So we know that H1 for cos 45 is equal to H1 for 4. So H1 is basically 4 cos 45. And then we need to find H2 change. The height. Since it's halfway, so this angle will be 22.5. So H2 will be cos 45 is equal, sorry, cos 22.5 is equal to h2 over 4, since it's the radius, which is same. h2 is 4 cos. The change in h is basically, I guess h is equal to h2 minus h1, and just put that in the equation. So change in GPE equal to change in kinetic energy. Change in GP is basically 35, which is the mass, into 10 into 4 cos 22.5 minus the h2 minus h1, 4 cos 45 equal to half 35 half m v square. And from here, if we simplify it, we should get v as 4.1643 0.16 meters per second. Okay.